We're going to work through this exam 2 style question, and it's testing our knowledge of exponentials and logs and also our ability of using our CAS calculator. So it says, a cake is removed from a hot oven and placed on a bench to cool. The temperature T in degrees Celsius of the cake, T minutes after it is removed from the oven, is given by this right here, where T is greater than or equal to 0, where K is a constant. What is the temperature of the cake? What is the temperature of the cake initially? So to figure this out, what we're going to consider is, well, when is T equal to 0? So in other words, T of 0 is what? Well, we could just come straight to our CAS here and define this for ourselves. So we could come here and we could say, all right, we've got T of X, control this. It's 20 plus 160 times 2 raised to the K times X. Oh, and I forgot a negative there. So it's negative K times X. There we go. So notice I've just replaced my lowercase t there with x's, 20, 160 plus 2k, yeah. And now I could say, well, what's 2 to the 0? It's going to be 180 degrees Celsius. You could do this by hand pretty easily as well. I would argue maybe it's a little easier to do it by hand than typing it into your CAS, because you're simply going to go 20 plus 160 times 2 negative. Now, if I set this to 0, would you agree this whole thing would just be that? And then you're going to end up with 20 plus 160 times 1, which is just 180 degrees Celsius. So you can do it with the CAS, or you can do it by hand. If we look at our mark scheme over here, it tells us that you could either do it with your CAS this way, or you could do it by hand this way as well. So you can pause here if you want to have a look at that working there. All right, let's keep on moving now, chugging along. So next, we have the temperature of the cake 10 minutes after it's been removed from the oven is 100 degrees Celsius. So 10 minutes after it's been removed from the oven, it's 100 degrees Celsius. Show that K is equal to 0.1. So what you need to kind of appreciate here is the fact that they've given us a point. If they're telling us that 10 minutes after it's been removed from the oven is 100 degrees Celsius, they've given us the point 10, 100. And now we can sub that into our formula here. So we can say, all right, we've got 100 is equal to 20 plus 160 times 2 negative K times 10. Okay, then we do some rearranging. This will become 80 is equal to 160 times 2 negative 10K. Then you could divide both sides by 160 and get a half is equal to 2 negative 10K. Then once we're here, I would make both of my bases the same by simply taking the reciprocal of this and making the power a negative to get this. And now you can equate the indices. So now I'll come up here and I can say that negative 1 is equal to negative 10 to the k. So what I've done there is I have equated my indices because my bases are the same. And then I can just rearrange for k here. It's going to be 1 on 10 is equal to k. Therefore, k is going to be equal to 0.1. There it is. K is 0.1. We have shown it. Amazing. Let's look at our worked solutions over here, and you can see that they've gone about it in a very similar way as I've gone about it. They've gone with that, like that, made the bases the same, equated the indices, got that, and then they've said as required because that's what we were after from the very beginning. Perfect. Let's continue to chug along here. It says sketch the graph of this. So notice that I've no longer got a k there. My k is now defined as 0.1. So now if I come here to my CAS, I can come up here and I'm just going to replace this with 0.1 now because it is now defined. And it says on the set of axes below, indicate clearly any endpoints or asymptotes of your graph. So I need to sketch this thing. We can use our CAS here to help us out. So we can add a new doc here. We can add graphs. And then I can go, all right, I've got T of X here. If we can't find it, that's fine. We know that the maximum point is going to be 180, right? Because that's the maximum temperature that we found initially. So we can go window zoom, window settings. We know that our maximum Y that we really care about is 180. Let's overshoot that a bit and go 200. Let's go 0, our Y minimum. The greatest max, according to our scale, is 60. Let's just go to 80, so we'll overshoot a little bit. And then our X min, we'll just go to 0. Okay, and there is our graph there. You can see the shape of it here. What points do we have to include? We have to include endpoints or asymptotes of your graph. Okay, so what are we going to include here? Well, when we know, when t is equal to 0, we know that we're going to end up with 180. So let me come over here and let me say, all right, we've got 180 there, and let me write it as a coordinate, 0, 180. I know the general shape that it's going to take, but another thing that I want to make sure I put in is the asymptote. The asymptote is going to exist at 20 here. So let me come here, let me put in a line there. This will be t is equal to 20, because as you can see here, this is my t-axis. And then we want to make sure that we get this correct. So if I just come here for a second, if I go menu, trace, graph trace, what happens when my x is equal to 10? As you can see, I'm going to be at 100. So if this is 180, let's call this 100. It's going to be there. What happens when t is equal to 20? So I can come type in 20 here. It's going to be about 60. Let's call that 60. So we don't have to be, absolutely precise here, because there aren't grid lines or anything, but I want to be generally correct here. I don't want to be doing anything like wildly wrong here. And, now I'm at 40, so like now I'm there. So it's going to look something like this. I just wanted to make sure I wasn't descending too quickly. It's not as essential here because we haven't got grid lines that we're trying to match up, but still, we want to be as accurate as possible. And then we're getting very, very close, but never touching that asymptote. All right, so that's what I'm going to say our graph looks like here. And of course, you just want to tidy it up a little bit. Let's see what they've drawn for us here. Okay, so they gave us that, good. They said t is equal to 20, good. And they've given us that nice line here approaching the asymptote. So as you can see, the marks were assigned for the correct left endpoint. So that one here, correct asymptote, correct shape. So hopefully you're able to draw that somewhat successfully. All right, next, what is the range of the function? Well, the minimum value is going to be 20, but you're not going to include it. And we can go all the way to 180, and we are going to include that 180 there. If we look at our mark scheme here, sure enough, it is 20 to 180, 1 mark for that. Meaning that if you messed up the brackets, you would have lost that entire mark. Okay. Oh, sorry about that. I've got a COVID cough. What is the temperature of the cake 20 minutes after it's been removed from the oven? So what we're doing here is we're going, what's T of 20? We can come to our CAS, and we can put this in. What's T of 20? It's going to be 60 degrees Celsius. 60 degrees Celsius. Let's see what the mark scheme says. It says using your CAS, you can simply go T is equal to 20, T is equal to 60. Easy. That's what we said. Or you could do it by hand, but I don't want to do that. Next, how long after the cake has been removed from the oven is its temperature 25 degrees Celsius? So this is a solve now. So we want to go menu 3.1. I want to type in, where is T of X? Oopsie doodle. T of X equal to 25. Solve that for X. It's going to be 50 degrees. So remember, see how this is 2 marks? So I need to make sure that I'm showing correct working here. So solve T of, now I want to make sure that I use the correct notation in the question. In the question, there is no X. I've used that on my calculator, so I could graft it correctly, but it's actually T of T in the question. Solve this for T. Therefore, T is equal to 50. So 50 minutes. Now, let's look at our mark scheme to make sure that we've done this nicely. So as you can see here, it's got solve this, and it's subbed in 25. Oh, sorry, my bad. That should say 25. How long after has been removed the cake? 25 degrees. Sorry, that should be 25 there. So this is our working here. Solve 25 is equal to that. For T, T is equal to 50. The fact that we didn't have to write it out in full because T of T has already been defined for us, hasn't it? Yeah, so it's here. So that's fine. All right, keep on going. The best time to apply the topping to the cake is when the temperature is between 60 degrees and 40 degrees. For how long is the cake at that temperature? And for how long is the cake at a temperature that is best to apply the topping? All right, so take a second, see if you can figure this one out yourself. What do you think you would do here? And what working do you think you would need to get the full marks for it? So have a think for a second. What do you think you would have to do here? And see how you go with it. But give it a good go. All right, hopefully you're giving it a go, not just relying on me. I don't want these videos just to be you watching me mindlessly. I want you thinking as well, because if you don't think, it won't end well for you. All right. Hopefully you've given it a go. Okay, so what you want to do here is you want to sub in, so the best time to apply the cake is 60 degrees and 40 degrees. Okay, so what are we going to do? We're just going to do a bit of solving. So I would come down here, I would steal this. I'll say, all right, at what time is the cake 60 degrees? At what time is the cake 40 degrees? There we go. So that means at 20 to 30 minutes. So it's 40 degrees 30 minutes in, and it's the temperature is 60 degrees 20 minutes in and 40 degrees 30 minutes in. So there's obviously a 10-minute gap there that is best to put it in. So showing all of this now is all we really need to do. So what we've done here is we have solved T of T is equal to 60 for T. Therefore, T is equal to 20. And we have solved T of T is equal to 40 for T. T is equal to 30. And then we're going to say between T is equal to 20 minutes and T is equal to 30 minutes. That is for 10 minutes, because that's the gap. The cake is at the best temperature to apply topping. So really, the crucial piece of information there is 10, but because it's worth 2 marks, I wanted to make sure that I had everything I needed there. If we look at our mark scheme here, you can see that you get 1 mark attempting to solve the equation for T. So using the CAS, we did that, and 1 mark for the correct answer. Okay, we continue. Next thing is asking for, this is a long video. Next thing that it's asking for is find the average rate of change of temperature of the cake between T is 20 and T is 40. So how do we find the average rate of change of something? So to figure out the average rate of change, what you want to do is you want to go T of 40 minus T of 20 over 40 minus 20. So you want to get the difference in the y over the difference in the x. So that means we're going to end up with, once we put this all in, 30 minus 60 over 20, which is going to be negative 1.5 degrees Celsius a minute. Now, I'll put a little caveat here. You're not really going to get questions like this yet. This is more of a calculus-inspired question. Calculus, we'll see in calculus. We'll see in calculus. But not right now. You probably won't get these rate of change questions now, but you will get them when we start calculus very soon. Okay, last one. Over time, what does the temperature of the cake approach? This is a nice and easy one. Looking up at our graph here, you can see that it's slowly, but never actually going to approach 20 degrees Celsius. So I can write 20 degrees Celsius. And then if we look at our mark scheme here, from the graph, as T increases, the value of T approaches 20 degrees Celsius. And we're all done. That is it. There's our answer to H as well. Hopefully you found this helpful and have a good understanding of how to approach these types of questions. All right, I'll see you later.